Jai Hind all of you. Welcome again. Today again we are going to discuss the array and pointers part 3. I am Dr. Aditya Pratap Singh, Associate Professor IT Department, Ajay Kumar Garg Engineering College. So in the previous lectures we have covered the definition of array, like what array data structure is. So array is a data structure which has an ordered set of homogeneous collection of elements stored in a contiguous memory allocation. That means we are storing similar kind of elements, for example, height of students, for example, name of a person. So all the characters will be stored. For example, I want to store the numbers. I want to store the possible values of a variable. So such kind of values which are of similar type, homogeneous type, that will be used in array data structure. So we have covered what array is, how array is stored in the memory, how array is declared, how array is declared and initialized in one go, what effects, like if we are not giving size, what will happen? If we are not giving size but supplying some values, what will happen? If we are giving size and supplying less or more values, what will happen? So that we have already covered in part 2. We have discussed very simple example of finding minimum value in an array as an example implementation of array. So today in part 3, let's start. What we have already done, we have discussed, like there are certain restrictions that are supposed to remember while using these arrays. Like for example, we are having A and B, two arrays. So we cannot use assignment operator with array variables, as array variables contain, or the name of array contains the base address of the memory location where it is stored. So one base address cannot be directly assigned to another base address. That means we are not copying the element of one array element to another array element. So that will not logically right, that is not philosophically what we are trying to do with assignment operator. Like in any other situation, for assignment operator, the left hand variable will be assigned the value as of right hand variable, or whatever this expression will calculate, that value will be stored in left side variable. But in this situation, we are having both arrays, array A and array B. So if we want to do this, like we are doing the elements of array element B to put in array A, but this cannot be do with the help of assignment operator. That we need to understand. Why it is not being done? I have already told you, these array names are the base address of, or the first address of the memory location where they are stored. So in this situation, what will happen? The address B will be stored in address A, and these array elements are not normal variable. The name of array will be treated as a constant pointer. Constant pointer. What is a constant pointer? First, let's understand what is a pointer. So pointer is a special variable that holds the address of another variable. Understood? The pointer is a variable which holds the address of another variable. So in this situation, A and B are the name of arrays, and as I I have already told you that name of array stores the base address of the memory location. So they are behaving like pointers, but the C language has kept them as a constant pointer. As in constant variable, what happens? I hope you remember that we cannot manipulate the value of a constant variable. We cannot change the value of a constant. So in the constant pointer also, if pointer is pointing to some memory location, we cannot change that memory location. But here what we are doing, we are assigning the memory location pointed by B to A, but A is a constant pointer, so it cannot be changed. That is the problem here. That's why the assignment operator cannot be directly used with array variables. I hope I am succeed to make you understand why this cannot be done. Another thing is, we cannot use equal to operator. This was assignment operator and this is equal to operator to directly compare. Equal to operator is used to compare two values whether they are equal or not. So this equal to operator we cannot directly compare in case of array variables. So we cannot use like this if A is equal to B, if A and B both are name of arrays. The reason behind this also is the same, that the name of array variable is a kind of pointer, a kind of constant pointer which holds the base address of the memory location where these array elements are stored. So if we will compare these, then array A is having name A is having a address, B is having a address. So we are actually comparing the addresses of the arrays rather than the reason or the intention of comparing two arrays is always comparing their elements. So we are not here, if we use equal to operator, then we are not comparing elements, we are comparing just the base addresses of these two arrays. So it's not logically correct to use this operator for comparing two arrays. So for that purpose, we have separate functionality, or we need to develop a logic to compare, but we cannot use equal to operator. Now, the scanf or printf functions which we use to read a variable or to display a variable, that cannot be used directly with the name of arrays, or array cannot directly read from the user using scanf variable, or it cannot be directly displayed on the screen using printf variable, printf function. So in that situation, what we need to do? We have to use a logic. We have to use a loop construct for displaying each element of an array, or for traversing each element of array. We cannot directly use scanf for the complete array. I hope you are clear that why we cannot use scanf and printf function for array variables. So let's traverse some interesting facts about arrays also. First, array name is a constant pointer, which I have already told you. Why it is a constant pointer? Because array name contains the base address. Base address, let me make you understand, like we are having this array, it is having some values like 1, 2, 3, 4, 5, 6. But what are the addresses? Like this address is 1001. So what will be the next address? What will be the next address? Please calculate. What bytes are required for one element? 4 bytes. So we need to plus 4. So 1005 will be the address of element 2. 1009 will be the address of element 3 and so on. So what this array name will have? Array name will be having this 1001 because this will be treated as base address. This 1001 is a base address. So array name contains base address, but they are treated as constant pointer. That means they cannot change their values. So array name once initialized or once it is pointing to array elements, it cannot be changed to point another array. Array name once initialized, once declared, it is pointing to a memory location, but it cannot be used to point to another set of elements during program because it is a, by default, it is a constant pointer. So arrays don't store their size. Array in case of C programming, we are giving size to the arrays, but there is no provision in the compiler to have what size array is having. That means what will happen if by a logical mistake we are traversing beyond array, then this is possible in C programming. Like I am having size of an array is 5 and I am accessing A5, A subscript 5. So that will be the sixth element because 0 to n minus 1. So C will not give error for that. Okay. Let's try to understand. They do not track their size. So you need to pass the size manually or sentinel values, for example, for strings as a terminator. So size must be passed explicitly. Whenever we are using a function or we are passing this array to a function, in that situation, we need to pass the size explicitly because arrays by default, they do not have their size value. Like array do not care for array bounds that I have already told you. For example, like if I am having int a5, that means the index value will be 0 to 4 n minus 1, 0 to n minus 1. So for that purpose, here if I want to traverse all the values of this array, I need to use a for loop. Like I am having int I is equal to 0, I is less than 5, I plus plus. And what I am doing? I am printing this. So I have printf %d a of I. So I am printing these values. But if I write like I is less than 6, then also compiler will not give any error. That will be a kind of logical error. We are moving beyond the limit of array size. As the compiler does not have the size stored along with the array, then it will not stop us. So we will access the next memory element and definitely we will have some garbage value there. That may be some security problem also. We are intruding in, maybe we are intruding in some other variables space which is stored just after that array. So such kind of problem may occur. In scenario of this, we need to be cautious while accessing array elements that we are not going beyond that array. Okay. So Multi-dimensional arrays. Multi-dimensional arrays are stored as a single block. They are stored as a single block. What it is saying, like for normal array or one dimensional array like A5, so what will happen? We will have a block 1, 2, 3, 4, 5. So we will have a block like this that will store element, each block of size 4 bytes. But in case of multi-dimensional arrays, like if I am having A, I have told in part 1 that arrays can be of single dimension or multi-dimension. Multi-dimension means there may be 2-dimensional arrays, there may be 3-dimensional arrays, and the dimensionality can be checked with the number of subscript that I have already discussed in part 1 lecture. So like I want to have a 2D array. So I am having A, 2 and 3. So 2D array will be a kind of table, row and columns. So first subscript specifies the number of rows and next specifies the number of columns. So it will be like there are 2 rows, so okay, and we are having 3 columns. So it will be index 0 0, it will be index 0 1, it will be index 0 2, it will be index this 1 row 0 column, 1 row 1 column, 1 row 2 column. So it is logically like this, but in memory it will not be stored like this. What will happen, like we can have a rope and so rope we are going this way, but again we are using like this. So it will be stored, total elements are 3 into 2, 6. So 1, 2, 3, 4, 5 and 6. So index 0 0, 0 1, 0 2, 1 0, 1 1, 1 2. So it will be stored. In memory it will be stored as a contiguous memory location as a single block rather than in the form of table, because in memory it cannot be stored like this. So memory will be allocated definitely in contiguous memory blocks, but indexes we are having 2 indexes, one for row, one for column. So indexes will be like this. This is basically this 0 1 0 2 like this. Okay, so these are some good factors which we need to understand while using or before using arrays. Designated initializers are there for arrays. So we can create like int ARR 5. So if I want to store a particular memory at a particular location in that array, I don't want to supply all the elements. If we supply, then it is supplied at 0 location, first location, second location serially, but we can give designated initializers. So I have specified at index 2 value is 10, at index 4 value is 20. So here like here you can see at index 2 value is 10, 3 and index 4 value is 20. So what we are doing, we are providing a value that is designated for that particular location. We are not providing any values, but the rule which we have already learned in previous lecture, that if we will supply any value at the time of initialization, declaration and initialization, that value, what will happen, remaining values will become 0. So here you can clearly see that we have passed only two values at index 2 and at index 4, and the remaining values become 0. They will not be garbage or random values, they will become 0. So another, let's understand another example of displaying a largest element of a float number array. So let's try to develop a simple program. Here you can clearly see we have started, we have taken some variables and we have taken a larger amount of memory reserved for this array, that is 100. And after that we have taken total number of elements 1 to 100, that maximum we can take 100 elements in that array. So we are taking elements from the user. So user have told us that we want to use this time as n. So we need to read those values. So we are giving here a message each time, enter number, and I is coming from 0, but we generally don't use in numbering, we start from 1, 2, 3, 4. That's why I have used here I plus 1. So element number 1, element number 2, element number 3, and user will supply that element. It will be a float value. So we have used %f format specifier, and in the scanf we use address. So we use here, this is what? This is address of operator. Address of operator. So we have stored that value at location ARRI. This is how we read all the elements supplied by the user, and now we need to find out the largest element. So what we can do, here we have used array for I is equal to 1, I is less than n, and incrementing I by 1 every time. So if ARR 0 is less than ARR I, then ARR 0 will become ARR I. This we are doing. So we are going to have the maximum element in ARR 0 location, or at 0th index we will store the maximum or the largest element. So we are comparing each element with ARR 0. If it is larger, then we are storing it here. And finally we are printing it. We have used here %.2f. That means 0.2f means we are going to display only 2 digits after the decimal. So for that, the format specifier can be manipulated or qualified with value 0.2. That means only 2 digits after decimal. So we are displaying array 0. Okay, let's try to develop another better version of it. What you can do? Please think about it. What improvements we can do in this program? What improvements we can do? So let's change this program a little bit. Okay, I'm going to do another version. Let's have like hash include stdio dot h, and we are having int main. Let's start. I may have an array, I may have some size. So let's have integer I for traversal of array, and n for size of array, and a float variable max for storing the largest value. Let's read the size. Printf, enter the size of array, I have used these colons, they will look better on the screen, and we can use scanf for reading this value. We are reading integer value, where we are reading address of n. So we have read the size of array in n. Now we can declare a array of type float a of size n, this. So whatever we require, number of elements we require, we are storing or we are creating only that, we are reserving only that memory. Okay. So now we need to read each element of an array. So for that purpose, we can use for loop for I is equal to 0, I is less than n, I plus plus, and in that we can use printf enter element. We can give number also, so like percent d, which element, I plus 1, and we can read scanf, we are reading a float value at address of a I. So we have declared an array, of required size, then we read all the elements of an array here. Now I want to find out the maximum or the largest element in that array. So for that situation, what we can do, for finding the largest element, first we can have max equal to a of 0. That means we are storing the first element into max. We are taking first element as the maximum element. Then after that we can use a loop for I is equal to 1, I is less than n, I plus plus. We have used this loop from 1 because a0 we have already taken. So let's check if max is less than a of I, then what we need to do, max equal to a of I. So we have stored this final, and after that we can display printf the largest element is %f, which is largest element, max, and this is the final. So we will use return 0 and close the main function. So this is how we can calculate. So that is another version of simply another version of this program, where we are using optimized version of array initialization, as well as we are using another version of having or finding this maximum element. So, we will do some good examples in coming lectures again. Till then, thank you everyone. Jai Hind.